Alright, in this section, we are going to learn about system of linear equation and its application. Okay, what is a system of linear equation? Now, when we have more than one linear equation, then we call this a system of linear equation, right? So now, from what we have learned previously, we know that for a linear equation, it can be written as y equals to mx plus c. All right, for example, y equals to 2 over 3x plus 2. Now, this linear equation, right, we can actually rewrite this one in the form of ax plus by equals to c. Right, for example, right, so to rewrite this, we first multiply the whole equation by 3. So y multiplied by 3, we have 3y equals to, now 2 over 3 multiplied by 3, then we have 2x, and 2 multiplied by 3, we have 6. All right, so multiply the equation by 3, right, by times 3, we have 3y, times 3, we have 2x, and times 3, we have 6. Now, then we can actually bring the y over we can bring the 2x over to the left-hand side. We have negative 2x plus 3y equals to 6. All right, so you can see here, now we have rewrite the linear equation in the form of ax plus by plus c. Okay, where the a is negative 2, the b is 3, okay, and the c is 6. So from here, ax plus by equals to c, this is one linear equation. All right, and dx plus ey equals to f is another linear equation where the d is a number, e is also another number, and the f is also another number, just like this. Okay, so as you can see here, now we have two linear equations, so we call this a system. Now, to solve the system of linear equation is actually to find the value of x and of y. All right, so it means that we want to find what is the value of x and what is the value of y, so that when we substitute it to the first equation, it is true, and when we substitute into the second equation, it is also true. Now we call this, all right, we say the value of x and of y that satisfy both equations, right? So now there are many methods to find the value of x and y, right? There are many methods to solve the system of linear equation. Okay, so we are going to discuss three methods in the following section. All right, so now the value of x and of y that we found later, they are actually the intersection point of two linear equations in the graph. All right, I repeat, all right, for each linear equation, we can actually draw a straight line. Okay, we learned this before. So for when we have two linear equations, we actually can sketch two lines. Right, this is line 1 and line 2. And the answer we found, the solution, the answer we found is actually the intersection point here, the x and the y. All right, we are going to discuss this one in more detail later. All right, let's take one example, and we are going to use this example to explain how to solve the system of linear equation using the elimination method, and also another one is the substitution method. Okay, suppose that the manager of a factory is setting up a production schedule for 2 models of a new product. All right, so this manager of factory is actually planning, right, to set up a schedule for 2 models, right? So let's say we have model A and model B. All right, so model A requires 4 resistors and 9 transistors. Model B requires 5 resistors and 14 transistors. All right, now what is resistors and transistors? You can actually Google, they are actually electronic components. All right, so one model A, we need 4 resistors and 9 transistors to build it. All right, and for one model B, we need 5 resistors and 14 transistors to build it. Right, from its suppliers, the factory gets 335 resistors and 850 transistors. How many of each model should the manager plan to make each day so that all the resistors and transistors are used? Okay, now do you understand the questions? Okay, so we want to find out for each model, model A and model B, how many of them should the manager plan to make so that all the resistors, right, 335 resistors and 850 transistors are all used. Okay, to solve this question, right, it is always good that we come out with the table. Okay, you can see here from the questions, right, or from the story, we actually understand that there are 2 models and there are 2 components, all right, resistors and transistors. Okay, so we are going to fill up the table, all right. Then from this table, we can actually build our equations. Okay, now beside this, all right, we also have the total. All right, the total, since the total is for resistor and transistor, so we are going to write the total here. Okay, let's begin with the first information we have, first piece of information we have. Now, it says that model A requires 4 resistors and 9 transistors. So how should I write? I should write here 4 resistors for model A and also 9 transistors. Okay. And then for model B require 5 resistors and 14 transistors. So for model B, resistor 5 and transistors 14. Okay, for total, all right, the resistor they get from supplier will be 335 and 850. Assume that this is the supply they get each day. All right, so now from the table, we have the information. All right, so what do we want to find? We want to find how many. Okay, so you can see here the word how many. Now it means that they are unknowns. Okay, they are unknowns. So unknown, right? We can set as A for model A and the B for model B. Now, of course, you can use X and Y. It doesn't matter. All right. So, but since we have model A and B, all right, I'm going to use A to represent the quantity, how many units of model A, and to use the B to represent how many units of model B. Okay, now since we are going to use A and B, then we have to declare the variable. All right, so we say let A be the quantity of model A. All right, student, now you have to declare the variable, right, so that your reader know what is A and B. All right, so let B be the quantity of model B. Okay, so we have A and B. All right, now since for model A, all right, the quantity is A, all right, and for model B, the quantity is B. So how many resistors in total they need for each day? All right, now for example, if the quantity for A is 5 units, then the resistor will be 4 for each unit. All right, 4 resistor for each unit times 5 units of A, it will be 4 times 5, right? Okay, so therefore, all right, since we know the variable is A here, therefore now it will be 4A. 4 times A represent the quantity of the resistor required for model A. All right, and for model B, it required 5 resistor for 1 unit of model B. Okay, so how many in total do we need for model B? So it will be, for example, if the quantity for model B is 10, for example, and for each unit of B, they need 5 resistor. So in total, it will be 5 times 10, right? Therefore, since we are using B, so here this is B, then here will be 5B. So we have a 5B here. Okay, now we apply the same concept to the transistors. So we have 9A and 14B. Okay, so A represents a total quantity for model A. Each A require 9 transistors. So in total, it will be 9 times A. All right, so on. Now from here, we can actually write 2 linear equations now. So for resistors, we can actually write 1 equation. And for transistor, we can also write another equation. So I'm going to write the equation here. So it will be, all right, this is 4A is the total resistor for model A plus 5B is the total resistor for model B, and the total resistor is 335. Okay, so it should be the total resistor. And now 9A plus 14B, it should be 850. All right, now we have a system, and we are going to solve this system to find how many of model A and how many of model B should be produced. Okay, so beside the elimination method, we can also solve the system of linear equation by using the substitution method. So in the following section, we are going to learn how to use the substitution method to solve the same system of linear equation. Okay, so now I'm going to start this by rewrite the equation again. So 4a plus 5b equals to 335. This is equation 1. And 9a plus 14b equals to 850. This is the second equation. Okay, now to solve this system by using substitution method, first we need to choose one variable to be replaced by another variable. So you have to choose, right? Now, for example, if I choose A to be replaced by B, so I'm going to write this way. So the A will be, now I'm going to bring the 5B to the right hand side. So it will be 3, 3, 3, 5 minus 5B. And this is equals to 4a, right? If I bring the 5b to the right hand side, all right, 235 minus 5b, right, equals to 4a. So then we bring the 4 to the right hand side, it will be divided by 4. So this is equation, from equation 1, we get the a. However, we are going to write this as equation 3. Okay, so you can see here from equation 1, so I'm going to write from equation 1. All right, we get that A is 335 minus 5B over 4. So I'm going to substitute now this one into the second equation. All right, so substitute equation 3 into equation 2. Okay, please take note that this equation 3 here, we actually get this from equation 1. So we cannot substitute this one back to equation 1. Okay, so we have to substitute this one into the equation 2. All right, to replace the A, all right, replace the A with 335 minus 5B over 4. Okay, so this is what we are going to do. So now 9a, I'm going to replace with this one, 9a, right, from equation 2, right, 9a. So the a, now I'm going to replace, right, a is equals to this one, so replace by this, plus 14b equals to 850. So you can see here, now after I replace the a with the b, now for this equation, I only have one unknown, which is b. Okay, I only have one unknown, which is b. So we reduce the variable from two unknowns to one only. So next, I'm going to simplify this equation. First, I want to take away the denominator. So what do I do? How to take away the denominator for here? We multiply the entire equation by 4. So multiply the entire equation by 4. We have times 4 here. We have 9. 3, 3, 5 minus 5b. Right, so when we multiply 4, so we cancel off this. All right, and multiply 4 here for 14b, so we have 56b, and multiply 4 to 850, we have 3400. Okay, so next we are going to continue here. All right, so further simplify this, 9 multiply 335, we actually get 3015. Now you can see the values are very familiar, right? So we have all these value are in the discussion before. Right, so 9 times 335, right, 9 times 5, 45b, okay, so 45b equals to, okay, before that, plus 56b equals to 3400. So solve this, we have 11b. And bring the 3015 to the right hand side, become minus. And from here we will get, alright, this is 385. And the b will be 385 divided by 11. And we will get, the b is, okay, 35, right? Okay, let's check. All right, here we will get 35. All right, so you can see we are getting the same answer. Now, finally, how to find the A? To find the A, we are going to substitute 35 into equation 3. So substitute, all right, B equals to 35 into equation 3 here, into this equation. Okay, into 3 here, and so we have A equals to 335 minus 5b over 4, and solve this, we will get 40. Okay, so we can see, right, we're getting the same answer. Right, it's 40 units for model A and 35 units for model B. So this method is called substitution method. Alright, so what do? We are going to replace one variable by another one. In this discussion, I replace A with B. Alright, so after that, substitute into the other equation. Alright, the other equation here, and simplify and solve the equation. So we get one variable. Finally, substitute back to the previous equation to get the A. Right? So now the answer we get here, we can actually check, all right, whether the answer we get is correct or not. Okay, so I want you to remember this one, this two equation first. 4a plus 5b equals to 335, and 9a plus 14b equals to 850. All right, remember this because I'm going to clear the screen now. Okay, so let me clear the screen. All right, so now we can actually check the answer we get. All right, we have 4a plus 5b equals to 335. And we have 9a plus 14b equals to 850. Now, how to check if our answer is correct? So we can actually check here. See, now the A we get is 40, right? And the B we get is 25. So by substituting these two equations into the system, 4 times 40 plus 5 times 35. Now using calculator to solve this, what do you get? If you get 335, it means that your answer is correct. Okay, if you get 335, means that your answer is correct. Provided the next one also you get the answer. All right, 9 times 40 plus 1435. All right, key in this into your calculator. Now, if you get 850 for the second equation, and if you get 335 for the first equation, now it means that your answer is correct. So this is how we check our solution. Okay. So as I mentioned earlier, there are 3 methods we can use. Actually, there are more than that, but we are going to discuss 3 methods to solve the system of linear equation. Okay, so the first method we are going to discuss is called elimination method. Okay, so I'm going to rewrite the system here. We have 4a plus 5b equals to 3, 3, 5. Okay, and 9a plus 14b equals to 8, 5, 0. Okay, we let this be the first equation and let this be the second equation. So when we mention second equation, that will be this one, and when we mention the first equation, it will be this one. Okay, to solve by elimination method, first we need to choose one variable or one unknown to be eliminated. So you have to choose. Now you can choose to eliminate A, or you can choose to eliminate B. Now the word eliminate means that we are going to make one of these two unknown disappear. Okay, so let's say I choose to make A disappear. I want to eliminate A. So this is what we are going to do. First, we are going to find the LCM to make the coefficient equal. We call this process balancing the coefficient, right? So we are going to balancing the coefficient, make the coefficient to be the same value. Okay, so 4 and 9, right? What can we do to make them equal? Right, we can change them to 36, right? So we are going to take the first equation times 4 times 9 equals to 36. So 4 times 9. So 4 times 9, right? 36a now we have. And 5 times 9 we have 45b. And 335 multiplying 9. So we get 3015. Okay, right, so this equation is from 1, all right, but however, we are going to label it as equation number 3. All right, so at the same time, we want to change the equation to the 9a to be 36 as well. So, all right, we are going to multiply this one by 4. So 9 times 4, we have 36a as well. And for others variable, we have to multiply together as well. So we have 14 times 4, it will be 56b. All right. And 850 times 4, it will be 3,400. Okay. Right, let me double confirm. Yeah, it's 3,400. So we are going to label this one as equation 4. Okay. Right, so now we have now 36a and 36a. So we can eliminate the variable a. So what do we do? So we can take equation 4 to minus equation 3. Okay. Before we proceed, can I take 3 minus 4 instead of 4 minus 3? All right. Yes, you can. All right. Just that for this system, I can see I have 3004 here for equation 4 and 3015 for equation 3. So I'm going to take the larger number to minus the smaller number. Therefore, I'm taking 4 minus 3. Okay, so but if you want to take 3 minus 4, it should be okay, but here you will get a negative number later. All right, so now 4 minus 3, so 36a minus 36a, we get 0, 0a. Right, this is how we eliminate the a. So 0a, we are not going to write this. Now, however, 56b minus 45b, then I will get 11b. And 3400 minus 3015, what do we get? We get 385, right? 350. And from here, 350 divided by 11. All right, so the b will be 385 divided by 11. So what do we get? We get 35. So what does that mean? It means that the manager has to make 35 units of model B each day. Okay, so that's how we find the B. Now, how do we find the A then? So we can actually take this value, all right, substitute into one of this equation. Now we are going to take the easiest one. So which equation do you think is the easiest one? Right, the easiest one is equation 1. So we say substitute b equals to 35 into 1, equation 1 here. So then we have 4a plus 5b, 35. All right, b is 35, is 335. And now the 4a will be 335 minus 5 times 35. Okay, so this is equivalent to, all right, 335 minus 535 is 160. All right, 4a is 160. All right, so then a will be 160 divided by 4, which is 40 units. All right, so at the end we know, all right, the company should make 35 units, okay, of model A, and okay, sorry, 35 units of model B, and 40 units of model A. Right, so this is the solution by elimination method. So the third method we can use to solve the system of linear equation is by using the graphical method. So we can actually sketch the graph and from the graph to see the intersection point. All right, so now this is another example, but however, I'm going to use the same example, all right, and to show you the graph here. Okay, so from what we have just now, we have 4a, so I'm going to write 4x plus equals to 335. Okay, so now we have an equation here. All right, so this equation represents 4x plus 5y equals to 335. All right, so I'm using x and y because for this system, we need to write x and y, right? If we write a and b, it doesn't recognize. Now, for the second equation, we have 9a plus 14b, which is y, equals to 850. Now, so if we plot the graph accurately and using the graph paper, so we are able to find the intersection point here, and you can see the intersection point is exactly 40 for X, which is our A, and 35 for B, which is 45 for Y, which is our B. Okay, so you can actually use the graph paper and draw the two straight lines to represent two linear equation, and the intersection point is actually the solution for this system.